Hi, guys. So today we are going to be reviewing solving equations. Now, this is something that you did last, May or April during our online learning. Some of you guys did a great job watching the videos and learning online. Some of us struggled a little bit, and so we didn't actually get this concept. We are going to spend one day reviewing one-step equations. So some things that we need to point out here. First, we need to be able to identify what the word inverse is. Some of us, it might be coming right back to us. Oh, yep, I know what inverse is. Some of us, we don't remember. So again, we'll be able to identify inverse. We'll be able to show how to solve one-step equations. And then later, next week, we'll learn how to show two-step equations. A couple things that are really important in this section. You have to show your work just like I do. If you do not show your work, you will not get full credit. I kind of joke this chapter is Heinz way or the highway. You either show your work like I do or you don't get full credit. Again, making sure you show your work is incredibly important in this section. So we're going to review and I guess maybe learn for some of us, what is a solution of an equation and what does this symbol here mean? Go ahead, discuss with your table and see what you can come up with. Alrighty, so let's go ahead and talk about what a solution is and what those things mean. So a solution of an equation is a number that makes the equation true. So again, some number that makes an equation true. That's what solution means. The symbol, an equal sign with a line through it, actually means not equal. Remember, you should be taking notes during this time. You should be writing things down. That's the expectation. To determine whether something is equal or not, to determine whether the solution to an equation is true, what we do is we plug the solution back in and solve using order of operations. If both sides are equal, then the solution works. If both sides are not equal, it's not a solution. So basically, guys, we're like substituting and solving. Continue writing if you need. We can pause the video. Let's go ahead and look at some examples here. So is the given value a solution? Yes or no? So first, we have to substitute. So let's look at this first one here. P plus 22 equals 54. We're asking the question, does P equal 28? Well, we substitute. So instead of P, I'm going to put in 28. So 28 plus 22 equals 54. Well, let's see. What is 28 plus 54? 28 plus 22. I can do that math over here if I need. You do have calculators, though, this chapter, so you could just type it in. 8 plus 2 is 10. 1 plus 2 plus 2 is 5. So this really says 50 equals 54. That was my solve using order of operations. Are they both equal? Yes or no? No, these are not equal. You can put a line through that. Not equal. 50 does not equal 54. So, can P be 28? No. P does not equal 28. I want you guys to try this one. It's a little bit more tricky. Substitute and solve using those order of operations. So first, we substitute that m equals 6 into our equation. So we really have here 3 times 6 minus 2 squared. And we're saying for now that equals 24. Simplify inside our parentheses first. So we have 3 times 4 squared equals 24. Order of operations says exponents are next. So 4 squared is really 16. So 3 times 16 equals 24. If I type that into my calculator, 3 times 16 equals 24, or 3 times 16, I get 48, and then we carry down that equals 24. Does 48 equal 24? No. Oops. Line through our equals sign, no. M does not equal 6, because if M equaled 6, our answer would be 48, not 24. Let's go ahead and learn what an inverse operation is and which operations are inverses to which. Talk with your table and see if you can remember what this was from last year. All right, so there are 4 operations in math. We've got addition, subtraction, multiplication, and division. Those are our 4 basic math operations. Every type of math you do is built off of one of those 4 types of operations. Inverse operations are the opposite kinds of math. They can undo each other. So if I add 5, I undo adding 5 by doing the opposite. I subtract 5. They cancel each other out. Adding $5 to your bank account and then going and spending $5 on Starbucks, they canceled out. I'm back to where I started. So again, inverse operations are opposite kinds of math. They undo each other. That sentence right there is pretty important. If you're not taking notes, you should be. The opposite of addition is subtraction. The opposite of subtraction then is addition. They're kind of like buddies. They're opposites of each other. The opposite of multiplication is division. And the opposite of division is multiplication. Knowing the inverses are incredibly important in this chapter. All right. Now we're going to talk about what this math properties of equality say. This says that if you add, subtract, multiply, or divide, if you do any type of math on both sides by the same number, the 2 sides will stay equal. I want to point out there that word both sides. So if you do one thing to one side of the equation, and then you do the same thing to the other side of an equation, the equation is still true. So for example, when I look at this 2 equals 2 over here, on the left side of the equation, I added 3. So on the right side of the equation, I also added 3. 2 plus 3 is 5. 2 plus 3 is 5. 5 equals 5. Still true. Whatever you do to one side of an equation, you have to do to the other. If you do it to one side, you have to do it to the other as well. This works with variables and algebra as well. So in this example, you can see that I subtracted 5 from this side, which means I have to subtract 5 from this side, because then they're still equal. Well, a plus 5 and a minus 5 cancel each other out. So really, this equation is left with m on the left, because these guys canceled out. 11 minus 5 equals 6. So that's how we really can solve equations, and we'll look at a lot more examples. But to sum up this slide, whatever you do to one side of an equation, you have to do to the other. Take notes, says it in big bold letters, so you probably should write it down. To solve equations, first, you write it down, especially if you're virtual. Make sure you copy the problem down correctly. Simplify if you can. Remember, we did combining like terms the last few days. If there's anything you can combine, do that first. Show inverse here, and it says on both sides. I'm going to even highlight both sides because that is so important. Again, showing the inverse on both sides. Solve it. Cancel out what you got to cancel out. Solve what you got to solve. And then last but not least, we can check our answer by plugging our answer back in to the original question and seeing if they match. So these steps should be written down in your notebook at this point. They are really important. Write and simplify. Show the inverse on both sides. Guys, if you don't do step number 2, you're not getting credit. Show the inverse on both sides. Solve it and check your answer. So let's go ahead and look at what an example of that would look like. So my equation was solve x minus 3 equals 18. And you guys, you might be able to do that in your head. That's great. That's not what I'm looking for. I'm looking for, can you use inverses to solve? So step number 1 here was to write and simplify your equation. So I wrote x minus 3 equals 18. There weren't any like terms on either side of my equals, so I'm good to move on. Next, inverse operations on both sides. Well, I can see here that I was subtracting 3 from my variable. I'm trying to get my variable all alone. So what I do is I do the opposite of minus 3 on both sides. So on the left here, I said minus 3 plus 3. If I did it on the left, I got to do it on the right. Now I can solve. Well, a minus 3 and a plus 3 cancel each other out. All that's left over here on the left now is this x. That's all I've got, so I just carry him down and rewrite it. Now, over on the right, I have 18 plus 3. I can do that math to get 21. So again, my minus 3 and my plus 3 cancel out. All I'm left with is my variable. And then on the other side, 18 plus 3, because if you do it to one side, you got to do it to the other, gives me 21. Now down here, what I did is I took my original equation, which was x minus 3 equals 18, and I substituted my answer, x equals 21, into that question. So 21 minus 3, is it 18? Yes, it is. I have my final answer. So again, showing that inverse on both sides, solving, and then checking, did I do it correctly? Let's go ahead and you try this one in your notebook. Make sure you show those inverses on both sides. We'll pause the video while you work. All right, let's go over this. Step number 1 was to write the equation down and simplify if you can. All I see is an x, a variable, and then a lonely number, minus 45. There's nothing else I can do there. So I just write my equation. X minus 45 equals 72. Now I need to do the inverse on both sides. So I need to figure out what is the opposite of taking away 45, because that's what I'm trying to get rid of. I want to get my x all alone. So whatever's attached to the x, we got to get rid of. Minus 45 is attached. So I do the opposite, which is adding 45. If I add 45 to one side, I have to do it to the other. So I add 45 again. Look in your notebook. Did you add 45 on both sides of the equation? All right, so here I have my minus 45 and my plus 45s cancel out. They're all gone. So all I have left is my x. I can bring it down. Over here, I have 72 plus 45. You do have calculators. If you needed, you could type it in. But I can do this one in my head. 2 plus 5 is a 7. 7 plus 4 is an 11. So I think the answer is 117. But I can check my answer just to be sure. So my original question was x minus 45 equals 72. Well, I think x is 117. So I can say, does 117 minus 45 equals 72? Type it into the calculator, double check. It does, which means my answer of x equals 117 is correct. How did you do? Did you show your inverse on both sides? Did you solve correctly? And did you check your answer at the end? Let's go ahead and look at another example. We have x plus 39 equals 81. So step number 1, write and simplify. Combine like terms if you can. I don't have any like terms on each side of the equal, so I'm good to go. I just write my problem. X plus 39 equals 81. Step number 2 is to show my inverse. Well, I'm trying to get x all alone. So whatever is attached to that x, I need to get rid of. Looks like I have a plus 39. How do I get rid of a plus 39? Well, I subtract 39 on both sides. If I subtracted it on one side, I have to subtract it on the other. So my 39s cancel each other out over there. I'm just left with x. 81, take away 39. You have a calculator, so you might as well use it. We have 81 minus 39, 42. That's what I think the answer is. But I can check my work by substituting back in. So I think that x is 42 plus 39. Does that equal 81? Well, I type it into my calculator. 42 plus 39 equals 81. Check. And I solved my problem. It is correct. So guys, there's no reason you should be getting questions wrong because you just substitute back in and you get the same answer. All right, let's go ahead and you try another one. X plus 9 equals 10. Remember, you got to show your work on both sides. All right, let's go ahead and see how you did. So to get rid of a plus 9, I do the opposite, which is minus 9. But if I do it to one side, I have to do it to the other. So my plus 9 and minus 9, they cancel out. All I'm left with is this x. Then I have 10 minus 9, which is 1. So I think the answer is 1. I can substitute to check though. So x plus 9 equals 10. I think x is 1. So 1 plus 9, does that equal 10? Well, it does. So I did it correctly. How did you do? Did you show the inverse on both sides of the equation? Did you get x equals 1? And then did you check your answer to make sure? Go ahead and look at an example again. This one, though, has multiplication in the question. I'm trying to get x all by itself. I'm solving to get x alone, trying to figure out what x is. Now, you might be able to do it in your head, but we still need to learn how to use inverses because you're not going to be able to do all of them in your head. Inverses work every time. So I'm multiplying by 9. The opposite, or the inverse of multiplying by 9, is dividing by 9. So again, to get rid of a times by 9, I do the opposite and I divide by 9. But if you do it to one side, you have to do it to the other. So my 9s cancel each other out. All I'm left with on that side is an x equals 81 divided by 9, which is 9. Let's check our answer. It says 9 times x, so we say 9 times, well, in this case, 9. Does 9 times 9 equal 81? It does. Therefore, x equals 9. Let's go ahead and you try this one in your notes. Make sure you show those inverses on both sides. We'll pause the video while you work. So to get rid of timesing by 4, we do the opposite and we divide by 4 on both sides. Now in the previous example, I wrote the division symbols divide by 4. Remember that the fraction symbol also means division, so I'm just using a different symbol this time. I'm still dividing by 4. My 4s cancel each other out. I'm just left with y equals 32 divided by 4 is 8. I can check my answer to make sure I did it correctly. So 4 times y, instead I'm going to say 4 times 8. Does that equal 32? It does. Circle my answer. How'd you do? Did you show your inverse? Did you solve? And did you check your answer? Let's go ahead and move on to a different type of problem here. Now I've got division. I'm trying to get this m here all alone. How do I get it all alone? Well, right now, there's a divide by 2 attached to it. So I have to do the opposite. So instead of dividing by 2, I'm going to times by 2. If I do it to one side of the equation, I have to do it to the other. Now this one looks different because usually the variable was on the left. Now the variable is on the right. It doesn't change anything. I'm still trying to get the variable alone. So whatever's attached to the variable, I got to get rid of. So my divide by 2 and my times by 2 cancel out. I'm left with m. And on this side, I'm left with 5 times 2, which is 10. So I have m equals 10, or 10 equals m. Same thing. I can check my answer. My original question was 5 equals m divided by 2. So I say 5 equals 10 divided by 2. Is that true? Yep. I have my final answer. So even though I flipped the equation around on you, you still do the opposite type of math and then solve. Go ahead and you try this one. We'll pause the video while you work. All right, so to get rid of that divide by 5, we times by 5 on both sides. My 5s cancel each other out. All I'm left with over here is a k. And then on this side, I'm left with 7 times 5, which is 35. Checking my answer at the end is 35. divided by 5? 7? It is. There's my final answer. How'd you do? If you got it wrong, why? Where did you go wrong? Let's go ahead and I want you to find this one. Diego and Ashley solved the same exact equation using inverse operations, but each solved it in a different way and got a different answer. Who do you agree with, Diego or Ashley? Why? Talk with your table. What do you think? Okay, we're going to look at a little bit trickier one here. 16 less than W totals 28. So I have a sentence here. First, I need to write an equation that matches this. So there's a few things I want to look at. First, the word totals jumps out to me because totals really means equals. So I know my equation is going to equal 28. Now I have this word less than. Less than means subtraction. But as we learned last year, less than is a special subtraction because 16 less than W really means W minus 16. Remember, anytime you add less than, fewer than, sooner than, the then switches the order of your subtraction. Usually, it's just left to right when you're reading a sentence like this, but the less than switched it. So now I have an equation and I can solve. To get rid of a minus 16, I'm going to add a 16 on both sides. These 16s cancel out, and I'm left with W to equal 44. And then, of course, I would check my answer. Go ahead and you try this one. First, you have to write an equation, and then you have to solve it. Try it in your notebook. We'll pause the video. All right, so here is the answer for this one. First, we had our equation. 22 divided by P equals 11. Did you get your equation right? This question actually had a typo in it, so we're just going to go ahead and move on. Really, it should have said P divided by 22, but we're going to move on and look at another example. Here's one. 7x plus 3x equals 820. First, we have to simplify this equation. As we practiced recently, 7x and a plus 3x can really be combined to make 10x equals 820. Then I can solve by showing my inverse on both sides. The inverse of timesing by 10 is dividing by 10. My two 10s cancel each other out, and I'm left with x to equal 82. Check your answer, make sure you did it correctly. You tried this one. Remember, simplify the equation if you can. And let's check our answer. How'd you do? Did you write the equation and simplify correctly? Did you show that inverse on both sides? And did you get the correct answer of x equals 24? Now we've got one with decimals. You don't change anything, guys. You just have harder numbers to work with. Luckily, you got a calculator. Try this one in your notebook. All right, let's check that answer. How'd you do? Did you show adding 3.54 on both sides? And then did you get the correct answer of y equals 18.64? All right, we've got another one. Go ahead and try it in your notebook, and we'll see how you did. Let's go ahead and check that answer. Did you write the correct equation? B divided by 6 equals 19. Quotient is a division word. Then show your inverse of timesing by 6 on both sides to get B equals 114. Here's some practice problems. Go ahead and try them in your notebook. And your homework today is to solve each equation in your notebook and then upload your work and answers into Google Classroom by taking a picture and uploading it there. Both equations I'm looking for.